Hi there, and welcome to this series of videos to help you with your maths revision. So giving you time to look at a question, decide how you would start it, and then going through the answers. A daily dose of 3 questions, 1 pure, 1 stats, and 1 mechanics. So let's get started. Each video will show you a question, give you some tips by focusing on the keywords and drawing out how to approach that question, and then giving the answers. So here's today's pure question. So did you read this question and see that you've got 2 points A and B? You're trying to find the equation of a straight line. So we're thinking y minus y1 is equal to m into x minus x1. But the line that we're looking for passes through this point 2, 8. Now, whenever you're trying to find the equation of a straight line, you need at least 1 point and you need a gradient. So what you're going to do is find the gradient of AB and then use the fact that it is perpendicular to AB, the one that we're looking for, and perpendicular lines have negative reciprocal gradients of each other, and then we're going to give our line in the form of ax plus by is equal to c, where a and b are just constants that we're going to find. So here are the answers. I've taken the gradient, that was 4. The negative reciprocal of 4 is minus a quarter. Using your equation of straight line, y minus y1 is equal to m into x minus x1, with the given point 2, 8 as x and y, and then go clear of fractions by cross multiplying, taking the 4 up to the other side, and then rearrange to get it in the given form. So for a histogram, did you remember that frequency is represented by the area of the bar, and you calculate frequency density by doing frequency divided by class width. At A level, the width and the height of the bars can be proportional to the class width and the frequency density. So on a histogram, you calculate frequency density by doing frequency divided by class width. So when you have a bar on a histogram, the frequency density is on the y-axis and class width is on the x-axis. When you times those two together, you calculate the area of the bar, and frequency is represented by the area of the bar. So here we're given that the 0 to 15 in the histogram that's been drawn has a width of 0.5 and a height of 6. So first of all, you need to calculate what would that be if we just drew a normal histogram rather than it being scaled and the bars being proportional. So if we were doing it normally, the class width of the first group is 15, and then doing frequency divided by class width, the frequency density is 5/3. So if we had a no scaling histogram, we'd have frequency density 5/3 on the y-axis and class width would be 15. But what's actually been drawn is a scaled histogram, and what you need to do is find what's happened to get you to that height of 6, what's happened to get you to that width of 0.5. So if you just do 6 divided by 5/3, you will see that that is a times by 3.6, and if you do 0.5 divided by 15, that is a times by 1/30. So on the bar they're asking you about, which is the 60 to 120, then if you calculate the frequency density again by doing frequency divided by class width, the frequency density up the y-axis for that bar would be 0.4, and we can see that the class width is 60, and then all we need to do to get to the new height is use the same scaling, so it would be times by 3.6, so that would have a height of 1.44, and then if we do 60 and times it by 1/30, that would give us a width of 2. So the key words here, we've got a ball being projected vertically upwards. So that means it's not being projected outwards. It's going to come back down along that same vertical line. It's starting 9.6 meters above the ground. The ball strikes the ground for the first time 4 seconds later. The particle is moving freely under gravity. So that means the acceleration is going to be 9.8. And we're asked to find the speed as it hits the ground for the first time. It's always best to draw a diagram so you can immerse yourself into what's happening with the question. Now we're starting 19.6 above the ground, so it's going to be projected here, and I've drawn the path of the ball as if it's sort of coming outwards, but because it's just being projected vertically upwards, it's not going to project out, it's going to go up and down just in a vertical line. Now it starts 19.6 above the ground, so that's where it starts. We don't know what the initial velocity, we just know it's projected upwards. We know it's SUVAT equations because it's moving freely under gravity, and that means we've got constant acceleration. So let's fill in what we do know. S stands for displacement, so how far has it been displaced at the end of the 4 seconds? It's going to be 19.6. U, we don't know what the initial speed was, so we can leave that blank. We're looking for the final speed when it hits the ground. Our A, it's acting freely under gravity, so that's going to be 9.8, and our T is 4 seconds. Now you might think that we should have a minus there because the ball has ended up below the ground, but by having the 9.8 as positive, that means that we are choosing that way as our direction, because if it starts off, obviously what's going to slow it down is minus 9.8, but I put 9.8 as a positive direction because when it hits the ground it's going to have velocity in that direction, and we want the thing we're trying to find to be positive. So if we're taking that way to be positive, then compared to where it started here, it's going to be 19.6 in the positive direction, even though it is below where it started. So you wouldn't put minus 19.6. Now the SUVAT equation that we're looking for, because we've left the one we haven't got blank, we're looking for a SUVAT equation that doesn't involve initial velocity. And the one to use is S is equal to VT minus half AT squared. So S, the displacement, is 19.6, T is 4, so 4V minus half times 9.8 times 4 squared. So if you work all that, take this term to the other side and then divide by 4, you'll have 98 divided by 4 is equal to V. So V is going to be 24.5, and that will be meters per second. Thank you so much for watching. Hopefully this has helped you with your revision. If you have any comments that you want to leave or any particular questions you want me to focus on in any of the 3 strands, the pure, the stats or the mechanics, please do leave any questions. Please do like and subscribe, share it with your friends, do all that good stuff. I would really appreciate it, and I will see you on the next one.